Alumni Association. Before I introduce our speaker, Brent Adams, I'd like to first thank the Chautauqua Institution, the CLSC, and the Alumni Association, and the CLSC for supporting this presentation. We're quite excited to have Brent here today. We first found his work when OpenAI, the creator of ChatGPT, and one of his projects.
You need to be a little louder. I can't hear you.
Yeah, sometimes you have problems with this mic. You think it's loud?
No.
Not enough.
Not enough.
Is this better?
Yeah.
Okay. So as I was saying, we're quite excited to have Brandon here today. We first found his work when OpenAI, the creator of ChatGPT, put one of his projects, MapGPT, as one of their top recommended lists. Talking with him, we discovered that in addition to being an incredibly talented programmer, he is a voracious reader and note-taker. His latest project, Commonbase Bot, is an evolution of the Commonbase book. You have my right here. Filled out. So without further ado, ladies and gentlemen, Brent Adams.
Hello, everybody. Is this good? Is this loud? Okay, leaning in and out. I generally like to lean out, but I'll be focused in on the microphone so people can hear me. Well, thank you all for coming out today. I'm really excited to discuss this topic with you. It happens to be like a passion of mine, and as Sam mentioned, I'm really into kind of the synthesis of both kind of what knowledge and note-taking could be, as well as kind of like what programming and AI could do. And obviously, you know, in our current climate, there's a lot of talk about AI in the news, there's a lot of fear-mongering, there's a lot of can I do this, can I do that, but I hope today to show you guys a utility case for both artificial intelligence as well as kind of the revival of a pretty old architecture, the Commonbase book, which has been used for a few hundred years now. So let's get into it. So I actually want to open this conversation with a kind of more open question, which this question is, what belongs to you? This might seem like a kind of ridiculous question to ask because we think a lot of things belong to us, our clothing, the place that we live, the food that we just ate, but in a lot of ways you could say that a lot of those things are passed through. The clothes you might donate to the thrift store after you're done with them. The house that you own is mainly owned by the deed that says that you own that house, right? Even your, certain relationships that you have with other people that you share with them change over time. So this kind of begs the question again, like what actually belongs to us? And I thought a lot about this, and kind of what I landed on was that I think that the main thing that we own, that we could really claim that we own, is our interpretations of things. So our interpretations of our memories, you can't necessarily keep that summer night on the porch at the hotel, the anatomy down the street, but you can keep your memories that you've made, the friends and the relationships that you've had there. You can't necessarily keep certain Herman Hesse's Siddhartha, but you can keep ideas from it, and you can kind of like take them with you for the rest of your life. So this really kind of inspired me to kind of build what I'm about to show you, to kind of like discuss some of the kind of implications of a system like this. So this is the preamble, it's the kind of idea of like, what are we actually saying? So this is going to be the outline of the talk. I apologize if the text is kind of small, but the first thing that we're going to do is we're going to go over the goal, which is kind of like where we want to be. I think when it comes to being we're in a literary society, voracious readers, but also where we want to be is in terms of understanding things as humans. I'm going to be talking a little bit about effortful versus effortless applications of knowledge. Then I'm going to introduce the problem of where we currently are, particularly the order and chaos of note-taking systems. And then we're going to talk a little bit about the history of how these systems came to be, both prehistoric and then post-historic, which was the introduction of writing. And then we're going to talk a little bit about the modern day computers. Then I'm going to introduce my research and my project, the Commonbase, and kind of make a claim for why I think that matters. And then finally, we will go over legacy and then wrap it up with some Q&A. So let's get into it. So I think that the goal of knowledge is figuring out basically, how do we have a effortless experience, both learning things and then sharing things and then finding things. That's most of what we consider knowledge, whether it's learning a new language, or remembering somebody's name, or processing a book, or studying a new field of study. It always goes through these kind of steps. So the first step is largely knowledge management. Knowledge management is when we want to remember the information that resonates with us, and we want to forget the stuff that isn't useful to us. And in general, what we'll do is we'll create systems to make this process of management easier. And this can be all the way up to like organizations having entire teams of people whose sole job it is to basically keep archiving the information. This is at the Library of Congress as well. There's just a lot of information out there, and we need somebody or some group of people who have the dedication and veracity to actually write it all down and put it under heading so people can find it later. Secondly, we want effortless knowledge transfer. So knowledge is only really as useful as you can spread it. And you can kind of give it to either students or other people, or even objects. I actually make the case here with this second line here about shorthand techniques, is that a lot of the things that we would consider technologies are actually just shorthand techniques for knowledge. Staying warm, a house is a shorthand technique to stay warm in the winter. And it might feel like, oh, well, that's interesting because, there's a lot of different houses, and different houses start with different blueprints. So it's like if you want to be able to stay in temperature control, you'll follow a pattern that builds you a thing that does that thing. So knowledge is generally like a wellspring that sometimes creates physical artifacts and sometimes it creates digital artifacts. So that's where we want to be. But thirdly, we want technology that works. I think that we all feel this in some shape or form, where we have some technologies in our life that seem to just frustrate us all the time, and we have other technologies that just seem to work all the time. And kind of like understanding why that second class is desirable, but also how to get there, I think is really important. And a lot of it really involves understanding both how technology works, but also how people actually use technology. A door with a door handle all the way to the top isn't really useful because most people's hands are somewhere in the middle of the top, for example. So let's introduce the problem state, which is where we currently are in the actual world. And we're going to start here by talking about note-taking again, because I think that this is kind of the root of Commonbase books, and this is how we're going to wrap this talk together, but there's a lot of ways that you can approach this. So this first person, hypothetical person, is kind of a person who is what we would call disorganized. They just kind of have notes everywhere, they have some on their phone, they have post-it notes, they'll just leave stuff kind of like all over their house and stuff like that and never be able to find anything. So that might be, you might see some parts of yourself inside of that, and you might feel stressed generally because you're like, okay, how do I find things and retrieve them that I've kind of written down and stored before? What's the point of doing all this storing if I can't find anything? On the other side, you run into people who have the opposite problem. They have these extremely rigid systems, and these extremely rigid systems are not at all adaptable to changing or adapting when the context of their life changes. They have a very clean, orderly kind of apartment, but they can't really add new things to it, for example, because they don't really understand where things might go because it'll break the current system. And then they end up getting stressed because, let's say, for example, they really get into woodworking and then they can't find any place to put it, or they can't find any place to store their notes about it because all of their notes in the past were about what they did for work. So that could be a good example of someone who's stressed out by boredom. But I actually am making the argument that both of these are really the same problem in disguise. I think that they're both just problems of scale. Because if you have a small orderly system or a small chaotic system, it's really not a problem to maintain. Like, you don't really run into any trouble finding a pair of pants if you only own 3 pair of pants, whether or not they're on the floor or they're hung up in the closet, right? So this, I find, leads to a really unhealthy relationship with our consumption and production of information, because we always fall prey to either rigidity or freneticism, and we kind of just oscillate between the two depending on where we are in life and what we're trying to solve for. So you're making the point, has technology made things worse? Because obviously I'm a programmer, as Sam mentioned, and I spend all of my time around computers, and I have to kind of like defend computers, but I also do think that in a lot of ways, the technology that we've created obviously has a lot of misgivings and a lot of follow-up points. So as you can see here that I said that technologies and tools have indeed made leaps forward, but most importantly, they haven't kept up with the information deluge that's kind of happened as of late, specifically. So people have been feeling particularly overwhelmed because they, every time you think that you've conquered a little bit of information, there's 5 more things waiting for you. So you never really kind of like get to catch up, and you're always buffering. And generally what happens here is that you'll get fatigued, a little bit listless, and you'll be kind of unsure about all the stuff that you read in the past and how it's affecting the present, and how it's going to change your judgment for the decisions that you want to make in the future. So I think in order to kind of discuss better technology, we need to understand a little bit more about the root of knowledge. So we're going to only take, this could be a talk in of itself, but there's only 3 or 4 slides here that are going to talk about very specific types of knowledge. And, you could argue that a lot of these are maybe like out of a hat, but that's kind of how it is. So the first type of knowledge that I want to talk about is prehistoric knowledge. I think prehistoric knowledge is kind of the natural selection, genetic kind of knowledge that happens when a creature is just kind of born, and then it automatically knows how to do a certain number of things. It just automatically seems to know how to walk. It automatically seems to know how to kind of like beg for food. Orcas kind of like mimicking their parents, so some things are kind of social learning, but they're kind of built in genetically. So this is kind of a type of learning that relies really heavily on randomness and environment. Most importantly, if we want to bring it to the human level, before writing was really a thing, there was obviously a big oral tradition amongst people where people would kind of tell each other stories, but these stories would die when the words left the person's mouth. We actually had no way of storing the words that were actually said by this person. And then it just became a giant game of telephone from generation to generation as people tried to recreate what they think that their parents told them and what they think their parents told them, and so on and so on. But importantly, we've always had, all creatures, all living creatures at least, have this desire to learn because it makes you more fit in the environments that you're in. So this worked for a long period of time up until we got post-historic knowledge, which I argue is writing. So I think that knowledge got a major upgrade when we could start inscribing it so that we could read it later. Basically what this allowed us to do was scale knowledge, both in the immediate, but also scale it over time. So you would be able to recall things across generations with perfect recall. You could read things that are thousands of years old and see exactly how they wrote it down when they were alive. And also more info that, so you don't, as we just, I argued earlier about the scale problem, if you feel like, oh, I can't store all this information in my head, if only I had somewhere to store it. And then it turns out you can store it on paper, or you can store it on clay, or you can store it on sticks and rocks on the ground, as long as you understand the symbols that you're writing. So this was a really big deal. And then, for a few other years we had this, we had like printing presses, we had increases of the velocity of writing and the number of literate people, but we didn't really have a way to deal with what I argue is another deeply important type of knowledge, which is kind of computational knowledge. Computational knowledge is the ability to kind of do math and to be able to do reasoning. So writing isn't really good for reasoning, which is why you can get beautiful poetry, but you can't really think the way that you would think by doing a calculation. So computers are very recent invention. The ENIAC was in 1946, and it's kind of crazy to think about how far things have come, where we all have computers on our wrists, and computers in our pockets, and computers outside, and computers, everybody has a computer with them, but yeah, they're less than 80 years old in terms of like what you might consider a modern computer. But what computers are really, really good at is solving functional problems, these math problems, really, really fast. So they can only do one instruction at a time, but some of the modern computers, for example, even a few years old actually, processors can do 1.7 trillion operations per second. So it's being able to do 1.7 trillion things by the time that you do that. Wow. So that's really fast. So, in addition to this, importantly, computers also have the ability to talk to each other, which gives us the ability to leverage things like the internet. Obviously, there was a CrowdStrike outage a few weeks ago that people kind of got to see what it's like when a part of the internet goes out and what it does to both our infrastructures and also our understanding of kind of like the flow of information in our societies. So this stuff is really important. Particularly, I wanted to choose writing and computers because I want to highlight two inventions for this talk that came about 2,000 years apart from one another, but I think are both relevant for the ultimate kind of presentation that I'm trying to make here. The first is commonplace books. So commonplace books are a technique for storing knowledge that has been used since antiquity. Some of the oldest commonplace books were written by Gallus, who lived in 125 AD, and he published his commonplace book, actually. It's called Attic Nights, and you can still find it today. But the argument for a commonplace book, they were really popular specifically in the Renaissance, when paper was still expensive, but literacy was now starting to outpace the ability to kind of get pen and paper, and now we almost live in the opposite world where it's really easy to write down data, but it's kind of hard to find out what data is worth keeping. So the main idea of a commonplace book is that only filtered information is worth keeping. The idea is that whether it's recipes or aphorisms or verses from the Bible or something like that, you only keep your favorite ones. And you don't really need to judge why one thing is more favorite than another. That's not really the task. The task is just to be like, this was interesting to me. I want to remember this later. I don't know when I'm going to use it, but I want to store it. So a good filter for that is resonance, which is basically just this concept of feeling like, oh, that's interesting to me, I'm going to write this down, or I'm going to think about this a little bit more, or this kind of like neuronal kind of like perk up thing that happens when something happens that strikes your fancy. What was really cool about commonplace books in particular is that they're extremely resistant to chaos, which means that, as a person kind of changes over the course of their life and they pick up different skills and they have different relationships, they can use the same commonplace book. So they can, be reading one type of book for a while and then move on to a different type of book. And their commonplace book would be able to kind of absorb all of that. Not fully, but we'll talk about a little bit of that in a second later. And the reason for that is that you're actually removing, again, the quotes or the highlights or whatever, or your thoughts, and putting them context-free. So you're removing them from their parent context and putting them in a separate context, which is the commonplace book. So I'm arguing that commonplace books are writing technology. So this is actually an example of John Locke's commonplace book. He published his commonplace books in the 1600s, and he was particularly known for coming up with good indexing, which is important for commonplace books too, because again, we run into that scale problem where if you only have one page and you only have 5 quotes on it, there's no problem. But when you get up to 50 quotes, 500 quotes, 500, 5,000 entries, then things can start to get a little bit hairy. So now we're going to talk a little bit about AI. Obviously, I was invited here to talk about computers. It's AI, in terms of the project that I'm presenting today, kind of operates as a background to the commonplace book. It takes a second seat, but it's really important, the task that it does. So the task that AI is accomplishing here, and I only have a few technical slides, so hopefully we can kind of get through them slightly painlessly. But the first one here is vector embeddings. So I have some images to explain in a second, so I'll just explain it and then we can look at the images and kind of rehash it. Where basically what a vector embedding is it takes a sequence of words, or a string, as we call it in computer science, and use machine learning to turn it into an address. And then basically these addresses make it really easy for computers, which again, remember, can do 1.7 trillion operations per second, to find these things and do things with them. So vector embeddings are a technology that came out about 5 or 6 years ago, if you really kind of want to be pedantic about it, maybe a bit longer. But more recently, with the advent of things like the GPT models, like ChatGPT, they became a lot better at understanding human concepts and the semantic similarity between things. So you can actually see an example here of how these sentences are turned into these addresses. So basically, you take in a string, like canine companion say, you pass it through the embedding model, and then it turns it into this list of numbers that computers understand. Because computers are much better at numbers than they are at words, and humans are much better at words than we are at numbers. So it's kind of a cool collaboration thing that we got going on here. So this is the kind of addresses, right? So you can see at the bottom left here, it says a quarterback throws a football. And in the top right, we have some things about kind of like animals. We have cats say meow, dogs say wolf, and cows say moo. And you can see the kind of the distances between these things is how close they are to each other in terms of their addresses. So when you take a string, and again, like canine companion say, and you tell your machine learning model, hey, give this an address, it's going to put it closer to other animal things than it is to things about sports, for example. And this is another example of kind of like what would happen if you kind of keep building this analogy out a little bit. This is actually a what we call dimensionality reduction in programming, because what's actually ended up happening is that there's like 1,536-ish dimensions in these numbers. So humans can't perceive 1,536 dimensions. So we actually run it through an algorithm that turns it into 3-ish dimensions, so you can see it on the visual plane. But that's not actually where they live. It's just where we think that they live. There's a lot of hand-wringing there. So those are our main two players, the Commonbase book and the vector embeddings, and we kind of now know what we're looking to solve, which is to kind of make knowledge management and transfer easier. So now we're going to be talking a little bit about my project with the Book Pro solution, which is the Commonbase. So a Commonbase is basically the combination of the traditional commonplacing for literature and specifically, but also the advent of computational indexing with machine learning that we just went over with vectors. So let's talk about using the Commonbase. So the main claim that I want to keep in mind here is that we want zero stress for storing, searching, and sharing knowledge. And the word stress is stressed here because basically the idea is that you want to think about how humans want to reference information, not necessarily how computers reference information, or we just end up in the same problem that we had before, where we have a big system that's too hard to manage because it's either too chaotic or too orderly. So the Commonbase format, this is like one of the last technical slides, I apologize, it's actually relatively simple. There's only 3 columns that you really need to pay attention to. The first is an input column, and an input column is basically just keeping track of again, the K9 says this, or hello world, or 2 paths diverged in the wood, yada, yada, yada. The citation is where you got it from. So this is kind of saying, oh, I got this from the Robert Frost poem, or I got this from when someone said this a week ago, or I took this image outside of Chautauqua by the bell tower. And then the vector is the thing that the computer does. So we don't really need to worry about that too much, other than the fact that the computer is deciding where these things actually live next to each other. And that's a big idea. And then finally, we have extensions. And basically what extensions allow you to do is that they make the point that knowledge is actually has a bunch of different dialects, right? So things that work on Google don't necessarily work on Facebook, and things that work on the printed page don't necessarily work on your camera. So a Commonbase book is only really as useful as you can change the dialect of the Commonbase book to fit the different kind of field that it finds itself in, or context that it finds itself in. So this could be, again, a web browser extension, or an e-reader extension for like Kindles and such, camera extensions and stuff like that. But they all go to that same data storage thing, which is just have a spreadsheet or a ledger. So, okay, let's talk a little bit about zero stress, because I've been talking about zero stress a little bit. So, zero stress storing, we'll do first. I think to store information with zero stress is that it shouldn't interrupt your flow state. So if you're listening to something, or someone says something that's interesting, or you're reading something that's interesting, you don't want to stop the process of paying attention in order to capture the thing that was being said. And there's different techniques and ways of doing this, but generally you can think of just kind of like highlighting while you're going along. That's generally a relatively good way to kind of like zero stress. Like, I don't need to tag this, I don't need to worry about this, I'll take care of it later. So what's really interesting about this too is that, again, storing I find is stressful when you have to context switch. So you're moving back and forth between I'm paying attention to I'm writing something, I'm paying attention to something else is happening. That's when we start building up stress in our brains. And we also, if we don't know where to put things too, this is also causes stress. It puts us in kind of like a judgment loop where we're like, oh, if I give it this thing versus this thing, then it might break, but if I do this thing, it might work, which is also very stressful. Moving on to searching. So to search information with zero stress, I think that we want to be able to find what we're looking for, right? That sounds pretty obvious, but it actually involves a lot of steps that are hidden inside of it. But I think that the main thing that causes search stress is the problem where we can't find a path to what we're looking for. So it's not necessarily that we mind putting in effort, it's that effort pays off. And I think that a lot of people don't mind looking for that book on the shelf if they know that they're going to be really happy when they find it, for example. But if you don't have it in the house that you're in, that's when it becomes kind of stressful. So then, we remember concepts in multiple ways, and we store them in multiple ways too. And I think that this is also really important to searching, because it kind of takes into account, again, maybe in between searching and storing, like, okay, how am I going to remember this a year from now? I'm not storing this right now for me. I'm storing this for future me who's going to want to see this a year from now. And how do I find that? And then finally, we get to sharing. So again, sharing is kind of the idea of teaching, to basically tell other people, or to turn it into objects. Like I said, turn the blueprint earlier of a house into a house, an actual house, by using wood and metal and such. And I think that basically zero stress sharing is the ability to kind of transmute to the context you're in. And that's a word there that probably can find a better word. But the idea is that you just are in another context and you're trying to figure out, how do I take this thing that I stored a while ago, I found it, how do I use it where I am right now? How do I make it make sense to the audience that I'm delivering to? For example, a lot of the vector embedding stuff, right? Like, I know that differently in my head than what I presented to the audience today, because I obviously, write programs using this stuff. So the way that I think about it is different than the way I have to speak about it, depending on the audience that you're speaking to, for example. So the reason that this is important is because, you share information through conversation, you share it through learning, and, importantly, we want to share enough information to be able to pass it on, which I think leads us to an idea of kind of like this idea of legacy, and also leads us to the idea of kind of like, why are we bothering kind of like storing all this stuff in the first place, and where we kind of building towards. So I think our legacy is kind of like, it seems, again, it's like one of those things that sounds obvious, but isn't really, just like the search thing, and it's kind of like, what are you trying to leave behind, versus what you actually end up leaving behind. What are your best lessons, the things that you regret, the things that you cherish? How are people who aren't you going to be able to find those things? And then over the course of your lifetime, how do you collect a record that you kind of feel happy to pass down? And you can see in these images here, so I didn't actually include a lot of pictures of the tool that I'm building, because it's like kind of like not pretty enough, I think, in terms of just like to kind of like show off, and it's like kind of like a tool that I'm building for myself, and a lot of programmers get it, but I didn't think it was kind of appropriate for this talk. But I did want to show these images here in particular, because I don't know if you can see the dates. They're pretty small, but I apologize. But basically, that first top one was in August. The second one is in June. This last one is in July. And this came back from a search of all these things that I stored back during those pieces of time. And I think that this is important, because if you run the same search and you get different entries from different moments in time, you can almost imagine your library automatically shifting and reorganizing based on the types of questions that you ask, and it doesn't really care about when things were stored. Again, it's doing that addressing thing. So sometimes you'll add a similar record, like we saw with the cows say moo or the dogs say bark, months, years later, and it will live right next to that entry that was initially put next to. And I think that that's really important, because that is what other people are going to rely on when they're searching for it. They're not going to be able to necessarily understand it the way you understood it, but they are going to want to use their neighbors and the things that they do understand to find it. So that's really important too. So now that I think that we've talked a little bit about kind of knowledge transfer and kind of like what would be effortlessly, and we talked a little bit about the history of kind of like writing and computers and how we kind of got here into the modern era, and then we kind of talked a little bit about my solution, which is going to accomplish both with vector databases, basically. Let's maybe kind of like revisit the goal that we started at the start of the talk. So I think what we really want to have actually is a effortless flow of knowledge. We want to have knowledge that allows us to basically kind of process it when it's time to process it, think about it when it's time to think about it, move on when it's time to move on, forget it when it's time to forget it. And we want technologies that fulfill that role for us. And most importantly, we also want to maintain flow as we scale. Again, like I said, if you only can deal with 5 things at a time, then that does a really big disservice to the 5 things that you just dealt with before that, because you're never going to deal with it again, because you can only deal with 5 things at a time. So being able to remember the things that we've done, and not have them necessarily get in the way of the things that we're doing, in order to make the things that we want to do better in the future. This really allows us to focus on kind of having that photographer's eye, and really kind of like paying attention to what we want out of the world, and kind of like how to take pictures that really kind of like inspire us, or kind of just like notice things better, have a deeper relationship with things in the world. And then we want to use our items to create what we're inspired by without using that much energy as well. So let's just review some key takeaways here at the talk. So the first one is that I think we own our interpretations, which is our relationship to the thing that's actually happening. And these can either come through our intentions or our memories. Number two, to learn is human. We're wellsprings of information. So we need really good systems. We're also sinks of information, right? We can receive information, we can also create information. So we need really good systems to both manage and transfer this, right? We can't really avoid that because this is just part and parcel of being human. Three, our knowledge systems tend to collapse under scale. So a lot of our knowledge systems can't really deal with kind of like the chaos or order, but thanks to vector embeddings and thanks to the 2,000-year-old technique of Commonbase books, we can start to kind of like maybe make a path through. Four, Commonbase books are a time-honored tradition of both mining and creating valuable insights that have been, again, around for thousands of years and kind of fallen out of favor lately. It's not bad. This is the last takeaway that always keep your clothes on there. It's the last. Okay. Nice. Number five, vector databases just came out a few years ago. Really cool already use of AI without having to think about what AI is going to be. It's something that AI already can do. So this is pretty exciting for kind of current technologies, but also as the technologies continue to improve, that's also going to get better, which is great. And then number six, the technology of your Commonbase basically just takes these two ideas and puts them into one, and is really obsessed with the idea of zero stress for storage, searching, and sharing of information. Just go here. And then over the course of your lifetime, I argue that a Commonbase or a Commonbase book that's kind of been enabled by vector databasing actually becomes like an intellectual asset class of sorts, where it's all of your interpretations that have been stored over the course of your lifetime that other people can search to, and then allows you to be more valuable to others, but also without having to go back and remanage that information as the world changes around us. So that's my talk. Thank you.